Good morning and welcome to today's Engaging for Missouri webinar. I'm Alice Roach from the University of Missouri, and today I'll be your host. With each of these 30-minute presentations, we intend to share research-based insights that leaders like you can apply in your own work to benefit and strengthen the state's agriculture and food system, hospitality sector, economy, communities, and families. Today, Ben Brown will present findings from a research project that has looked into how weather changes may affect crop basis and supply chains. Before I invite him to begin, I want to share a few housekeeping items. First, we'll close today with a Q&A session. Those of you who connected today via your computers may submit your questions in the chat screen. If you joined today by phone, then you may email me your questions at roacham@missouri.edu. Second, all attendees are muted and may not start their video. Third, if you encounter any technical problems during today's presentation, then you can let me know by either submitting a comment in the chat screen, or you can send me an email at roacham@missouri.edu, and I'll do my best to help you troubleshoot. And last, we will make a recording of today's presentation available. You can look for an email tomorrow that shares more about where you can access that recording. And you can also find an archive of previous Engaging for Missouri webinars on our Division of Applied Social Sciences YouTube channel. So now we'll transition to the topic of today's presentation, which is titled, "If It Pours When It Rains, Then How Do Midwest Crop Basis Levels Respond to Such Weather Extremes?" Presenting today is Ben Brown, who's a Senior Research Associate at the University of Missouri. So thanks, Ben, for presenting. If you could please unmute your microphone, we can begin today's presentation.
Thank you, Alice. Much appreciated for the opportunity to present today, and certainly looking forward to the questions at the end. We're going to go through a lot pretty quick, but hopefully we'll have time for questions. If not, feel free to reach out to me. When we picked this title, "When It Pours, It Rains," or "If It Pours When It Rains," I did not realize that we'd come off a rain shower where certain parts of the United States would have gotten 3 to 5 inches last night. But I was talking with some friends in Iowa, and they said they got 5 inches of rain in about a 6-hour period of time. Folks in Ohio were getting 4 to 5 inches last night as well. So certainly a relevant topic for what we want to discuss today. This is part of a larger research project that we've been working on for some time now, and we're excited to share the results, or at least our current findings of where we're at with this project. And we're excited to kind of wrap this up and move on to other new and exciting things as well. But certainly want to give credit to all the people that have helped on this project. And it was sponsored by the USDA's Ag Marketing Service. Teo and Wyatt Thompson and Mohammed Malbarak at Northwest Missouri State University now have all been a part of this, major parts of this. And we want to thank some of our graduate students that have worked tirelessly to pull together some of the data and kind of run some of the calculations on the backside of this. So I want to give thanks to everybody that's been a part of this and acknowledge our funders for this. I want to start off and talk a little bit about what is market basis, because this is something that it's a word that I have found people assume they know what everybody else thinks when they say basis, right? But basis can have many different meanings, and it's usually the difference between two different, or prices of two different attributes. Okay, basis has become newsworthy when we see big spreads between a port price or a futures contract and our local price, right? That tends to get people worked up, somewhat emotional. We see that in all sorts of commodities, not just row crops, but livestock, certainly fruits and vegetables as well. And so we can kind of break this down and think of basis in a couple different formats. One of the things I want to talk about is there's this concept of quality basis. And we see this a lot in wheat or malting barley when we're trying to get certain mill grade qualities of wheat, or a high enough protein content in barley to make beer, right? And these are largely influenced by supply and demand. If people are demanding higher contents, they tend to bid up that price. So we see a basis spread between that. We have this thing called temporal basis, which is the difference of price of the same products at two different times. So if you think about the futures market for like a December corn price versus your local cash price in September at harvest, for instance, we would assume that is the difference in basis. And this is what most people think of when they think of, or I shouldn't say most people, this is what a lot of farmers are thinking of when they hear of basis, right? You have this futures price, which is set on the Chicago Mercantile Exchange for many here in the United States or other exchanges around the world. And then you have a local cash price, where your local elevator is bidding for grain. And the difference between that is what we call basis. And basis can be both negative when futures price is higher than the cash price, and it can be positive when the futures price is less than the cash price, right? And so that's in a lot of ways what we think of when we think of basis, but there's also this function of spatial basis, which is the difference in prices of the same product at two different locations. So you can think of US yellow 2 number corn on the cash price in St. Joseph, Missouri, minus US yellow number 2 corn in Sikeston, Missouri, for instance. And the difference in those prices is largely influenced by transportation costs. We would assume that if that difference got so big that grain merchandisers would start arbitraging or taking advantage of that price spread and move grain from areas of low basis to areas of high basis, right? And take advantage of that. So in our study today, we're primarily looking at spatial basis between two points in the US market, between the Port of New Orleans and the local cash price. And this is important because when I show you some basis graphs a little bit later, some of these basis trends might look a little odd from the standpoint that we're not talking about this basis from a cash price to the futures market like we normally see it in agriculture. We're talking about two different points because we're interested a little bit in this transportation cost equation. Now, that's not to say that quality basis and temporal basis aren't included implicitly in these estimates, and they certainly are, but we're just not capturing that specifically. We're not capturing everything that's involved in basis either. It's hard to capture everything, and you'll see that in some of our results in terms of, there's some basis that's not, or some of our estimates aren't explaining basis to the full extent. And that's because we have these odd things that happen that really influence basis. Last summer, the I-40 bridge across the Mississippi River in Memphis had a crack in it, and it shut down traffic across the bridge. It also shut down the flow of barges and grain under the bridge as well, and created this pinch point where north of that pinch point, we saw basis fall because the demand for the product, suddenly had nowhere to go. They couldn't get the grain down the river. And so the basis was weakening north of that pinch point. But it also caused basis south of that pinch point or below that pinch point to increase because all of a sudden they had higher demand for their product because they weren't able to tap into the corn or soybeans north of the river. Right. So this is kind of what we're looking at. Our hypothesis or our research question is, does projected rainfall due to climate change scenarios increase the stress of our current infrastructure to a point that affects basis, corn and soybean basis specifically? We've talked about extensions to other crops, but in this study, just looking at corn and soybeans, we added temperature later. It was an expansion onto this, but this was something that has become newsworthy across all the media press, and especially in the ag news, as we see pictures like these on the right here, looking at US Mississippi River or Ohio River or Illinois River locks and dam systems flooded, and we can't get product up or down the river, causing the lack of grain movement, right? And similar to what I was just showing you with the Mississippi Bridge, is it creates these divergence between basis strengthening north of the pinch point, or weakening north of the pinch point and decreasing south of the pinch point. So here's kind of what we're interested in terms of how we include rainfall and temperature into our studies. When it comes to local conditions, we assume that increased precipitation and temperature could disrupt planting progress, change when the crops go in the ground. Maybe it's a year like 2019 where there was parts of the US that couldn't get the crops in, and so they were late being planted, and that impacted their development. We also assume that we have some type of growing season conditions that impact the condition or the production or the growth of these crops due to less rainfall, maybe higher temperatures in the summer, maybe more rainfall in the spring and fall that create yield changes. And so this map that I'm showing, or this illustration I'm showing you here, is kind of what we anticipate, or at least we think, in terms of a yield response, right? And so, or at least in terms of a basis that, at perfectly adequate precipitation and temperature, we would expect to see basis at its lowest price, just because we're producing high amounts of crops. But if we start adding too much precipitation to where the crops are flooding and growth development is slow, that we would see basis increase. The same thing if it doesn't rain at all, right? And the crops are stressed and we see some yield destruction due to lack of moisture and high temperatures, right? And then the third thing we were interested in is these regional conditions. So does extreme precipitation or increased precipitation create challenges on the river that prevent grain movement up and down the river system, right? So that previous slide I showed you earlier where the locks and dams were flooded, barges couldn't move, right? That's one side of the coin. But the other side is, what if the rivers get too low that we can't move barges, down the river, or we have to load those barges to loads that are less than what we would if the rivers were higher, right? And I probably didn't say that eloquently there, but the way I think about this is in terms of a canoe. Many of us have canoed down the river, and when the river is low enough and you put a lot of weight in a canoe, it drags along the bottom. So we have to find ways to lessen the load on that canoe to allow the barge to move down the river. So we're looking at this from a historical standpoint, mostly taking into account future climate change scenarios. And the reason we do this, or the reason we did this, is it is very difficult or nearly impossible to estimate the impact that improvements along the lock and dam system would change, or how they would change the basis or at least improve the transportation abilities to move grain up and down the river, right? It's hard to understand what future infrastructure improvements would do. And so what we're doing in this study is we're taking future climate change scenarios and we're adjusting historical basis bids, or adjusting some of these other points that I just talked about from precipitation and temperature to see how it impacts basis, right? And so our system, our plan of attack here is to estimate how regional precipitation impacts river water levels, and how river water levels, whether high or low, because remember, there could be excess flooding or not enough water to move grain up and down the river, creates river disruptions that impacts basis, how temperature and precipitation impact planting progress, how growing season precipitation and temperature impact local corn and soybean yields, and then certainly how all of those factors impact crop basis. So that's what we're trying to do here. So that's first step. Part two is to get out our handy dandy, I call it an adjuster, from a pencil, and to go back and apply climate change scenarios to our precipitation and temperature in the historical period and see and recalculate basis. That's kind of the idea here, is to recreate what basis would have been had future climate change scenarios been in effect in our historical period, and then to look and see, okay, how do these all differ and how does it impact basis, right? I do have a disclaimer here that we are looking at a lot of these in aggregate, and I'll show you some distributions across basis, but aggregate results can hide extremes, right? And so averages are wrong for everybody. They're either too high or too low, depending on where you're at. And we've certainly seen cases of this. So in a simplistic example, when you pinch a balloon, the air just doesn't disappear, it goes somewhere else, right? And it creates that bottleneck, kind of like what I was showing with the Mississippi River Bridge. You can do fun things by creating balloon animals by doing that. But in a more practical example, we see real world examples of what I'm talking about here just in the last couple of years. So this is the change in acreage in 2019 due to consistent and persistent rainfall. The first graph that you see there with blues and oranges on it, that's the change in that's the prevent plant acres across the country. Anywhere where there's orange is high amounts of prevent plant acreage, South Dakota and Northwest Ohio being primary areas of that. But then the graph in the bottom right shows the change in corn acres. And so what we see is, even though there was places across the country that weren't able to plant corn, there was places like Western Kansas and North Dakota that drastically increased their corn acreage, right? So as we squeezed certain parts and prevented acreage from being planted, other areas were responding to those market incentives and increasing their planting of corn or soybeans, whatever the case might be. Another example would be when we had the Chinese trade conflict in 2018. It shut off a lot of the demand, or it decreased the demand for soybeans in the upper plains but increased the demand for soybeans in the southern Mississippi River Valley as grain moved from the Pacific Northwest to now going out of the Gulf of Mexico. A little bit about our price data here. We used price data from Refinitiv for about 2,400 grain receiving locations across the country, and they're illustrated there in the map. Our time period is 2008 to 2020. For weather data, we used precipitation and temperature data from the NOAA and the National Oceanic and Atmospheric Administration stations across the country. These were all weighted to basically match precipitation and temperature data with those grain receiving stations. And so there might have been 3 stations in a nearby area, 3 or 4 stations, and we used a distance weighting to make sure that we were applying an adequate precipitation and temperature value to those grain receiving stations. And then you can just see a little bit about what our whole data set had in terms of descriptive statistics. So across our whole data set for this period, the mean corn basis was negative 80 cents. The mean soybean basis was negative $1.15. You can see kind of some of the other descriptive statistics. Our average diesel price during this period was $3.08 per gallon. And we'll talk about some of these others as we go through. One of the things that we did was we tried to correct, or at least account for, correct isn't the right word, but at least account for ethanol intensity. So during our period from 2008 to 2020, we had this growth in ethanol that created a domestic local demand factor that increased the price of corn, or at least the local price of corn in some of these regions. And so we were finding it difficult to go back much further than 2012 or 13 in our data set, because we had this demand factor that had grown during that period. And so thanks to Vince Brenneman at the Office of the Chief Economist at USDA, they had done some work to look at ethanol capacity and the intensity of ethanol growth across the country. We were able to incorporate that in our study to add more years into the forecast. Then a little bit about our climate change scenarios. We did not model any of these. We didn't want to take into the vast literature and all the work that's going into what happens or what climate change is doing. I don't think any of us are weather forecasters. We do markets, and that's enough for us. But so we took these from the National Oceanic and Atmospheric Administration for a period of changes looking at, so from 2006 to 2025, and then looking ahead to 2025 to 2044 across 4 different scenarios. So a low scenario, which was rather minor, so minimal changes, to a high scenario with some larger scenarios. And what you're seeing here is the graphs on the left represent precipitation change during this period. The graphs on the right show temperature change in degrees Fahrenheit per year, or an average of degrees Fahrenheit per year. And so these are the scenarios we're working from, and you certainly can see that some states, especially in the lower part of the Corn Belt, are expected to experience increased precipitation on an annual basis, while states in the northern part of the Corn Belt are anticipated to see relatively higher temperature over this projection period. So those are the things we're using. To get into a little bit of the results, and this largely follows the steps that I explained earlier. So step 1 was to estimate water level, and then steps 2 and 3 are to apply these climate change scenarios that I just showed you to see how it impacts basis, right? So the first thing that we did is we looked at, can we estimate how precipitation impacts water level in the areas that we're interested in? And specifically, when does water exceed flood stages, and when does it fall below our thresholds of what we're calling low water level? Okay, so that's the first thing. We had 4 locks that we started with. We had 2 along the Mississippi River, one at Dubuque, one at Canton. We had 1 on the Illinois River, and we started with 1 on the Ohio Basin. We ended up dropping that Ohio River Basin one from the standpoint that we found that it was very difficult to adequately capture that due to a whole bunch of other things that happen in the eastern part of the United States. For instance, soybeans could travel out of the Great Lakes, and we weren't accounting for that. So we had some logistical challenges with the Ohio River. So we ended up keeping the other three, 2 on the Mississippi, 1 on the Illinois. We summed precipitation over a 4-month period within these basins. And so if it rains in Wisconsin, we assume that eventually that rain is going to come, or that rainfall portion of it's going to come down the Mississippi River and show up at these lock systems. So that's how we did it. And what we found when we applied the climate change scenario is something that we largely expected, right? More precipitation, as we were seeing in our climate change scenarios, created more days of a flood stage or above flood stage for our 3 locks and dam systems all across all 4 scenarios. And it decreased the amount of days below what we're calling the low water level, or days below 9 feet, right? So these graphs are largely showing the same thing: more water going down the river system as we increase precipitation in the basins, right? Step 2, or at least our second equation, was to estimate planting progress. And certainly this is something that I've talked about multiple times, is, do we have average springs anymore? Well, in April and May here in Missouri, fields looked a lot like this. This was a picture I took just north of here, north of Columbia a little bit. This was in May. Preventing planting from really kicking off, decreasing the crop quality of the crops that we're growing. But then by June, and this was taken on my own family farm in western Missouri, we were really dry. Now, if you add the 2 up and divide by 2, you get an average spring. But we certainly know that's not always the case. And we've certainly had some years here where U.S. corn planting progress has been significantly delayed and challenged our ability to grow a crop. So when we apply our climate change scenarios to that historical period, we do see some adjustments in planting progress. Probably the thing I want to point out here is when we look at actual planting progress across all 4 scenarios, and sorry that I didn't label these better, but the top block there is the low scenario, then medium low, then medium high, and then high being the bottom one. We do actually see planting progress increases when we apply these precipitation and temperature adjustments due to future climate change. It increases. We actually plant earlier in the year rather than later, but probably an unexpected finding for us was that precipitation had almost no impact, or at least not out to the 3rd decimal, on planting progress across all 4 scenarios. Temperature was the dominant reason that planting progress increased. And so, by our assumption here is that as it gets warmer, the ground is warming up quicker and farmers are able to get out in the fields and plant at a much quicker rate. Whereas when we see those temperature adjustments, or excuse me, those precipitation adjustments, we're still able to get in and plant the crop. However, probably what's notable to farmers is that we're losing suitable field days in both the spring and the fall. And so if we look at just USDA data for April and October precipitation, over the last 25 years, we've lost about 5 days of suitable fieldwork conditions in the spring and 5 days of suitable fieldwork in the fall to get those crops in and out of the ground. Now, a lot of people say we're compensating that for larger equipment, and that's true. Equipment today is able to cover more acres in a day than we did 25 years ago, but we have less people. And so our planting capacity on a daily basis seems to remain the same. So as we think about what our data, or what our analysis is showing on the previous slide, is that, yes, precipitation is a factor, but we need to make sure to take advantage of those days when we're actually able to get in the field. And this is the same thing for soybeans, showing basically the same thing, that we're able to plant earlier, and that precipitation had almost 0 impact on planting progress. It was temperature that was driving a lot of that change in terms of when we were able to get in the field and plant. When we think about how weather and our growing season precipitation impacts yield, one of the trends that we're seeing is that, yes, while annual precipitation is actually increasing, the trends are showing that most of that precipitation is coming in the spring and the fall, at least here in places like Missouri and through Illinois and western Iowa, while precipitation in the summer is becoming a little bit drier, or we're getting a little bit drier in the summer months in places like Missouri. So that's just something to take into account. Temperature, largely warmer in the winter and a little bit cooler in the summer is kind of what these trends are showing. Now, our estimates for weather's impact or precipitation's impact on yield doesn't take into account some of these crazy or extreme weather events, right? So we had the Iowa derecho 2 years ago that flattened corn. We had a derecho this winter in Kansas that just kind of sandblasted the wheat crop. we're not really, our study isn't taking those into account. We're just looking at rainfall and temperature, but not necessarily how much rainfall we're getting in any one rain event. So when we re-estimate our yield equations, on the corn side, all 3 of the 4 scenarios, the low, the medium high, and the high scenario actually showed across our entire sample that corn yields increased. Only one scenario, the medium low scenario, showed that corn yields would decrease as a result of our climate change scenarios that we were using. When we look at soybeans, all 4 scenarios showed that the soybean yield across the Midwest, or at least our region that we're looking at, decreased. So increasing corn yields, decreasing soybean yields as a result of the scenarios that we're using. When we apply all of this to basis, what these graphs here are showing is the average of corn basis across our study period from 2 periods, an average of 2008 to 2011, and an average from 2016 to 2020. And so again, these basis patterns might look a little strange because we're not looking at basis from a cash price to a futures price. We're looking from one location to the Port of New Orleans. So maybe like Central Missouri to the Port of New Orleans, Central Iowa to the Port of New Orleans as well. And so when we run our regressions and try to estimate basis, there's a couple of things I want to point out, and a couple of things make sense. Ethanol intensity. What this is showing is as ethanol intensity within a region increases, basis for corn and soybeans also increase. That's probably not surprising, right? That's taking into account an increased local demand factor. On diesel, as diesel price increase, basis decreases, right? We would assume that diesel price is a relative indicator for transportation costs. And so as the transportation cost from a local point to the Port of New Orleans increases, it's going to push down the local price that elevators in the Midwest are going to bid for grain. And that gap is going to widen. We've already talked about precipitation and yield. I want to talk about exports. What we're doing here is measuring the value or the quantity of value of exports leaving the United States. And as exports from the United States increase, given that corn and soybeans are a large exportable product from the United States, we see that has a positive impact on basis as well. As exports increase, so does the basis value, and we assume that's an increase for demand in those local areas. The other thing I want to point out here is our flood variables for both flood and low water. When we have these scenarios of a higher flood threshold, or more flood days or more days where we have to light load those barges, we see a decrease in basis across the board in all 3 of our lock locations, right? And again, this is that burden on transportation costs that we talked about. When we apply all of these things to our basis equations, and we look at this across the distribution, what we see is that corn basis decreases at the 5th, 25th, and at the median, but it increases at the 75th percentile and the 85th percentile. Another way to say this is the distribution and basis across all 4 climate scenarios gets wider, right? So the locations where basis is increasing, it's increasing in certain locations, and we see corn basis decreasing in other locations across the country. Again, transportation costs, if it's viable, elevators will arbitrage those transportation costs and move grain from high basis areas to low basis areas in the future. The other thing that we looked at is breaking out temperature and precipitation across these four scenarios. And for 3 of the scenarios, precipitation decreased the basis. And again, this is largely due to that yield factor, right? So as yields increase, we assume it pushes down crop basis or corn basis, but temperature had an increasing impact on basis. And again, we think this is largely due to the local yield, or we have evidence to support this due to local yield, that as temperature increases, it could stress that crop, produce less of a crop, and result in local elevators increasing their bids for corn. So across our entire data set of about 740,000 observations, at the median, temperature increases corn basis. You probably don't see a lot of changes in there because these are relatively small changes that we're talking about, but certainly we do see changes as the previous slide indicated. When we look at soybeans, again, because we're shrinking that soybean crop in our study, or our study is suggesting that increased precipitation and temperature decreases soybean yields, we actually see higher basis values. And so compared to corn, where corn bases were lower on one end and higher on the other, across the board, we see soybean basis increasing at all four, or at the 5th percentile of the median, and then the 95th percentile. Precipitation, again, being a major player in terms of what's controlling that basis bid. So some concluding thoughts to wrap up here, and I apologize, I think I'm going long. Our study shows that increased temperature and precipitation does have an impact on corn and soybean basis across the Midwest. Increased precipitation in the river basin does increase the number of floods on the river given current infrastructure, and decreases the number of days with low water. Again, we would assume that more rain is going to create more water down the river systems. Temperature has a larger impact on planting progress compared to precipitation. This wasn't something we expected to see at the beginning, but certainly after playing with it and doing a lot of different testing to account for different aspects, temperature is a dominant factor in planting progress. Climate change scenarios are estimated to increase corn yields, except for one scenario out of the 4, while the scenarios that we're using are expected to decrease soybean yields across the country. Again, this is an aggregate, so you might see places, or the Eastern Corn Belt might be different than the Western Corn Belt. But then as a final remark, both corn and soybean basis bids distributions widened across the region. And that's largely signaling that there is some extra transportation cost associated with this, and that local yields are a dominant factor related to basis bids in the Midwest. So with that, Alice, I'll turn it back over to you. I'm happy to take any questions, or if we're out of time, I'm happy to email responses to people that have questions. But thank you for the opportunity.
Yeah, thanks, Ben. We are short on time, but I do want to pose one question to you. Producers can do little to prepare for weather extremes that have the potential to affect basis. But that said, what can they and other businesses along the value chain do to curb the effects of weather on infrastructure and basis patterns?
That's a good question. So, in terms of what can be done, what we're showing you here is that we had hoped to find that the infrastructure along the river, or at least the transportation from a local elevator to the river, was going to see challenges that was going to decrease basis. I think what our study showed is that yields, our study is showing that yields are a dominant factor in the changes of basis. And so there certainly are things that we can do to decrease those transportation costs, right? Invest in loss and river systems, decrease the cost along the river, working to improve the transportation from an elevator to loss and dams also decreases those transportation costs, and allow elevators to pass more of those returns onto producers. So that is something that is known, right? Decrease the transportation costs, increases prices. I think what we're finding is that what we're showing, and what we showed today, is that it's the local yield components that are the dominant driver of basis, and therefore are the biggest. That's where we're seeing the biggest shifts, and so it's hard to adjust for that outside of increasing drought resistant traits and investing in better technology seed to handle some of these changes. I fumbled that question quite a bit, but that's my answer.
Great, thank you. Well, it's time to close today's webinar. Thanks again, Ben, for presenting and sharing these research findings, and thanks to our audience for joining us. You'll see a post-webinar survey will either have already loaded in your browser, or it will do so shortly after you close Zoom. Please consider responding, as we'll use the results to improve the webinar experience and also brainstorm future presentation topics. Again, sometime tomorrow, you should receive a recording of this presentation, plus we'll include a link to where you can go to download the slides. On August 17th, we'll host our next Engaging for Missouri webinar. Bill McKelvey from the MU Interdisciplinary Center for Food Security and Lexi Joes from the Missouri Department of Agriculture will join me in presenting Clearing the Path for Marketing Directly from Missouri Farms to Institutions. Again, thanks for joining us, and I hope you have a great Wednesday.